All right, for this we're going to be taking the notes, the notes on controlling chemical reactions. So the first thing we have to understand is that we've talked about how in order for a chemical reaction to occur, the molecules have to physically contact each other. There has to be some sort of a collision between the molecules in order for them to react with one another, because if they're not physically touching, then they can't react. But it's a little bit more than just that. They can't just simply collide. They have to collide in the correct atom alignment, and they have to have enough activation energy. So if a reactant is in the correct orientation, but is not moving fast enough, if it's moving too slowly, then the molecules are just going to end up bouncing off of each other and they're not going to react. So even though they're oriented correctly, there's just not enough energy to make it happen. If the reactants are moving fast enough, right? So they have enough energy, they have enough speed on them, but they're not oriented correctly, then again, they're just going to end up bouncing. They're not going to react and they're going to bounce off of one another. So in order for that reaction to occur, they have to have both enough energy and be oriented correctly in order to collide and have that reaction. So in this case, this molecule steals one of the red oxygens off of it. So there had to be enough energy, and it had to be with the, red hydrogen. It had to be with the blue oxygen oriented towards the nitrogen, and it had to have enough energy. If the hydrogen was oriented towards the nitrogen, it wouldn't work. And if the oxygen wasn't moving, if that molecule was not moving fast enough, it wouldn't work. There are 4 ways of controlling chemical reactions. The first one is temperature. Temperature affects how rapidly the molecules are moving. We talked about how temperature and energy are one and the same. So the higher the temperature, the faster the reaction is going to happen, because the higher the temperature, the faster the molecules are going to be moving. And if they're moving really quickly, they're more likely to collide with one another and collide with that energy. Just like if I asked you guys to walk around the room and not hit anything, you'd be able to walk around if you moved slowly enough and not collide with anything. But if I told you to run around the room, therefore expending more energy, you'd have a greater chance of hitting a bunch of stuff and running into each other and colliding. So it's the same thing with the molecules. When there's low temperature, there's low energy. So the molecules are bouncing around slowly, just kind of meandering. But when there's high energy, they're zooming around and going all over the place, and so they're going to be hitting each other quite often. The next way of controlling a reaction is with surface area. So first we have to understand what surface area is. So imagine you have a 3D object. In this case, imagine you had a block of ice, okay? The surface area is how much of that object is exposed, how much of it is covering the outside of the block. So you would find the area of each square, add that together, and you would get the total surface area. If an object is broken into smaller pieces, if I take that block of ice and break it into a bunch of small pieces, I'm actually increasing the surface area. So if it's broken, the surface area increases. And the reason that is because when it's a big block, you can only touch the outside of it. All that inner core is protected. But if you break it into small pieces, suddenly there's all these other sides that are available for the reaction. So the greater the surface area, the faster the reaction. And the reason why this is because the larger your surface area, the bigger your surface area is. So the smaller your pieces are, the more broken up your object is, the more exposed molecules you have. So instead of only the outside of that block being available for reaction, all of those inner sides are suddenly now available as well. So you're going to have more exposure, so you're going to have a faster reaction. The next way of controlling a reaction is with concentration. Definition of concentration is the amount of matter in a specific area. So how much, thinking of it as concentration is how much do you have in a container. So when you fill your water bottle, if you have half of it full, you're going to have a lower concentration than if the whole thing was full. The more concentrated a substance, then the more likely those reactions, those molecules are going to hit, because there's more of that substance in that area, so your reaction is going to be faster. So again, the more concentrated your substance, meaning more of the substance in a smaller space, the faster your reaction will be. And that's just because the more concentrated it is, the more molecules you have, and again, the more likely you are to collide. So again, if going back to the analogy of the classroom, right now there's 18 of you, or 17 or 18 of you in the classroom. You all have your own individual space, and you can sit without touching each other. But if I brought in another whole class and suddenly it was 36 people, it would be a lot harder to move around without hitting things, to have your space and not be touching one another, because you would be more concentrated, because there's more of you in the classroom. There's more of you in a space. Now, there's two ways we can control this, and we can change concentration. The first way is you can simply add more of a substance. So if I was making salt water and I added just a tiny bit of salt, that would be a pretty dilute concentration, so not very concentrated. There'd be a lot of space for those salt molecules to be moving around. If I wanted to increase my concentration, I would just add more salt. The more of the substance you add to the liquid, the more concentrated it's going to be. The other way of changing your concentration is by decreasing the volume. So if I have a big beaker and I have my salt, or like say I have gas in it, then, the molecules can spread out. If I decrease the size of that beaker, suddenly they're more squished together, so they're going to be more concentrated. A way of thinking about it, again, using the classroom as a scenario, is right now you guys are all spread out within the classroom. If I said that you all had to move to the left side of the classroom, you would all become far more concentrated. And so changing the volume is one way of changing concentration, and changing the amount of substance is another way of changing the concentration. The last one is the catalyst. Now, a catalyst is a substance that increases the speed of a reaction, and it does this by bonding to the reactant. So it's its own individual compound, but it will attract the reactants from the reaction. So from the chemical reaction that wants to happen, it'll take those reactants and actually bond to them. And when it does that, it orients them in the correct way. Remember, we talked about how they have to hit each other, not just with enough speed or energy, but they also have to be oriented correctly. The catalyst physically pushes those two reactants together, and it makes sure that they are oriented correctly. So then they're able to bond more easily, because rather than bouncing around and waiting until they'll actually hit correctly, they're already oriented properly. This reduces the amount of activation energy that's needed, because the catalyst helps put them together. It's like a matchmaker. It takes each piece, gets it set up, and then connects the two of them together. What's really important to know about a catalyst is that while the catalyst helps with the reaction, it is not required for the reaction to occur. It simply speeds up the reaction. And so it's not technically part of the reaction. It releases the product and then goes on and tries to find more reactants to bond to create more compounds. So it just kind of moves around in the space of the reaction, in the beaker or whatever, trying to connect those reactants together. But it itself does not change and does not become something new or different. It just stays there until there's no more reactants to bond. So those are the 4 ways of controlling a reaction. We have temperature, which speeds it up because the temperature is energy, so it gives it more energy, so they're more likely to collide. We have surface area, which spreads or exposes more of one of the reactants so that there's more of it to react. We have concentration, which increases the number of reactants, so again, making it so that they're more tightly packed and so they're more likely to hit one another. And then finally, a catalyst, which physically brings the compounds together.